work with parabolas, ellipses, circles, oops, so I can spell, and hyperbolas. These are all what they still call conic sections. They basically come from taking a cone and slicing it. All the different shapes. What's nice is that the formulas for these things, there's all these different formulas and all these different things, the way things are going to look. You don't have to memorize because you take your calculator. There's a calculator restart and validation. Oh, whatever. If you hit the button that says apps, there's a button that says apps on it right next to where it says math. On that, there is an option that says conics. Mine says 4. I don't know if everybody should be right around 4. So if you hit option 4, you get these 4 equations. Did you get it? Okay, I'll have to do an update on yours, but when we get to having to need them more, you'll have it. Anybody else not have that on there? Okay. So if we hit hyperbolas for right, or I'm sorry, parabolas, hit option 4, you get 2 main. Obviously, this is a little bit different than what we're going to start with today. This is a shifted parabola, but if you look at it, it shows you a y squared or an x squared parabola, and if you look to the right, it kind of shows you the direction that they might go, left or right, or up and down. So for each one of these things, if you hit escape here, back out, let's go to ellipse. Each one of these has its own specific formula. And if you notice when you look at your pictures, it tells you whether it's being stretched vertically or stretched horizontally. Just by looking at them. Don't worry about memorizing these things. Again, it's going to be one of those things where we understand what each part means. And that's kind of the main thing. So today we'll talk about parabolas. Thursday we'll talk about ellipses. It usually takes a day and a half, which is perfect because then on Friday we'll do circles. Circles take about 10 minutes. They really do. They're very fast and easy to work with. That way we can double up a little bit extra time for the ellipses. Next week we'll do the hyperbolas, probably Monday, maybe Monday and Tuesday. It takes a little bit more time. And then we'll start worrying about shifting things and how the graphs look and how to work with all those and then how do you adapt and make equations and blah, 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 blah. We should be done with this. I'm guessing usually takes 2.5 weeks or so to get through all this stuff. And then that'll give us time to get into polynomials. Still have the time before we get to finals. I think we have 3 chapters left. We're about almost halfway. Okay. Anyway, parabolas. Don't write all this out. What you guys are going to be looking at today is a different way of working with parabolas. From what we've done in the past, on the marker, you guys have had parabolas were up like a cup, or parabolas were down like a frown. And you guys were always writing them out in terms of, well, I got ax squared bx plus c, or vertex form, or intercept form. So what changes here today is that we're going to have extra pieces to it. Every parabola has a vertex, but every parabola is looking at something. It looks at what's called a focus. There's always this thing called a focus. Every vertex for every conic section always looks at its focus. Okay? It always opens towards the focus. Now, what happens then with these parabolas now is that when we have a focus, there's going to be this distance here. That distance is balanced by something behind it. That something behind it is what we call a directrix. Okay? think of your eyeball. You guys have all done the eyeball, or in what's it called? Biology, I think, right? Anatomy, whatever it's called. Where your eyeball is focusing on something, and the image is broadcast behind it. Light, when it goes through a lens, it focuses and refracts the image to here. Remember how that works with mirrors and stuff? Just that stuff. Anyway, what's happening is, if you think about your eyeball, you've got what, the retina, iris, cornea, thank you. Slept through biology, so but you have all that stuff that's inside there, where that's why things counteract the balance. If these two values, if this is out of whack, everything gets fuzzy. That's why we wear glasses. That's why we wear contacts, to help balance where that way the distance between the focus to that vertex is the same thing as the balance behind it to what's called directrix. Now, one thing I wanted to show you here is, if my parabola is up like a cup, what's my A value? It's positive. Good. So if it's down, what was my A value? It's negative. Okay. Now, here's the thing. If I'm down, my focus is here. My directrix is up here. The directrix will always be the counterbalance of the focus. Does that make sense by the word counterbalance? So, and I'm not giving any values or anything yet. If this is 4 units away from the vertex, this would have to be 4 units the other direction away from the vertex. So if I went up 4, this would have to be down 4. That's where that works. That vertex is always going to be dead center between whatever directrix is and that focus. And again, I'll get into why all this stuff goes as we start looking at numbers here in a minute. Today, everything we do, or actually this whole week, everything that we do will be always centered at the origin. We're not moving things in space yet. We'll start doing that next week, so you don't have to worry about any of that yet. Excuse me. So let me show you what's going on. We know that you have y equals x squared is either up like a cup or it's down like a fountain. What if I told you that it can go left or right? You would scream. All right, guess what? It can go left or right. And x equals y squared goes left or right. Now, if you think about it, when you wanted to graph that, you have a button on your calculator that says what? Y equals, okay? So if I have x equals y squared, what would you do to get y by itself? Not square it, square root it. What happens when you take a square root over both sides of an equal sign? You get plus or minus. So go to your y equals real quick. Quit this first. And let's do a square root of x. And then do a negative square root of x. Graph it. Oops, gotta change my window. I'm gonna go back to a 10 by 10. Parabola turned over. Okay. So we're going to get these left and right parabolas as well. If it's positive, which way do you think it's opening? Right. Because what positive numbers go to the right, then negative numbers then go to the left. Okay. It's going to be fairly simple, but I just wanted to show you guys how this is going to go. Now, if this was a see if we can figure this out. So if my parabola is opening to the right, where's my focus? What's that? Does it matter where it is? I mean, it's somewhere positive. See where I'm going with that? It's somewhere over here. Depending upon what it is, we'll learn how to figure out where it's placed. But remember, that vertex always opens to the focus, whether it's opening up, right, down, left, doesn't matter. Now, earlier when we drew the directrix, it was a horizontal line. This was going up or was going down. What direction do you think it's going to be now? The directrix is always going to be the one line that would go through and touch the parabola at two spots. Okay. So left-right parabola has a vertical directrix. An up and down parabola has a horizontal directrix. Excuse me. Where this is all going to get to then, long way, is stuff like this. Again, I don't want you to write all this out. It's going to be this idea that we have an x squared parabola is now going to be written like this. X squared equals 4py. Where this p value, whatever this p value is, excuse me, is the distance from vertex to focus. If p is positive, it moves up. If p is negative, it moves down. When you think about what you've done in the past, you've had it written as y equals x squared. Okay. If you got y by itself, it would be 1/4 p, or 1/4p times x squared equals y. If you want to get back to where we were doing stuff last time. Here, this p-value, excuse me, is that distance, and if this is negative, it moves down. If it's positive, it goes up. Same thing if it's the other way. It's a y squared parabola, 4px, where again, that p-value tells you that it's positive or negative. So this is your up or down. This is your right or left. When we get into the actual equations and how things get placed, how you write it out, and how you find the equation for the directrix, it's super simple. Yes, ma'am? If P is the distance from the vertex to the focus, the opposite of P would be the distance from the vertex to the directrix. Yep. Move this down a bit here. So the opposite of P is the distance once we do a couple examples of this, of how things get placed together, you'll be like, oh, this is really easy. Because it actually is. You may not believe me right now. You have to trust me. Right? Well, you don't have to draw all those. I'll just leave that. Probably. It's the, yeah. It's the water right next to us. Now, here's what's going to go on. I don't like graph paper. You guys know that. I'm going to take this equation, and I'm going to identify vertex, focus, and directrix. I'm going to rough sketch it. So I have x equals negative 1/6 y squared. First things first, what direction is this going to open? It's going to go left. So y squared. So right away I know this is a y squared, so it's going to open to the left because it's negative. Okay. Once I do that, I'm going to write down the generic formula. x, excuse me, oh, right. Sorry, y squared equals 4px. That's my generic formula. Which means, what do I have to do? What do I have to get? What do I have to get by itself here? I want the y squared, right? Not just y. I'm just going to get the y squared by itself. How do I move that negative 1/6 times? Sorry. So you wind up with y squared equals negative 6x. You okay with me on that so far? Yeah. Which means then I'm centered at the origin. My vertex is at 0, 0. This p-value is some multiplier in there. I have to figure out what that is. But I know that the coefficient of x has to equal 4p. That number out in front has to equal the 4p part. So you solve for p. What do? Divide by 4, and we get p equals negative 6/4, otherwise known as negative 3/2. Okay. That tells me that my, excuse me, the focus moves to the left 3/2. There's my focus. The ordered pair of that focus is at, what is that? Negative 3/2, comma 0 is my focus. To counterbalance that, going the opposite direction from the origin, I have to go to the right 3/2. My directrix then will be a vertical line at x equals 3/2. And that's what it does. When we are working with these parabolas to get the curves, we don't have to find additional points with these. We're just doing a rough sketch. If you think about it, I'll come back to that later. That's basically what we're doing here today, guys. Figure out what direction it goes. Is it a left, right, up, or down? Get y squared by itself or get x squared by itself? Find your focus. Or find your directrix. And counterbalance through. Yes, ma'am. See how it's negative? So the y squared parabola is either going to go left or right. And if it's negative, that just means it goes left because negative numbers go left. Same thing as if we had x squared that was negative, they move downward. Yes?
Does the y being squared make it that sideways parabola, or is it just like it moves?
The y squared makes it the sideways parabola, yes.
And the x squared?
Yep. Yep. Is this a function? No, it's not. This is not a function. And why isn't it not? Why is it not a function? Yeah, you did. Because the math, because the vertical line test wouldn't. What's that? Well, no, I'm just. You can have math that aren't functions. I was just saying that this is technically not a function because if it was a function, x can't be in two cases at once. All right. Okay, let's try another one. So we have x squared, or x equals 3/4 y squared. I hate slashing fractions. I apologize for it. I can't see it. All right. Is this an x squared or a y squared parabola? It's a y squared. Is it positive or negative? So what direction should this open? It should open to the right. Okay, cool. So what I want to do is get the formula written out, first of all, in terms of y squared. So it's y squared will have to equal 4px, which means what do I have to do with the 3/4? By 4/3. So I'm going to get y squared equals 4/3 x. What do I set equal to 4p now? 4/3. What's p equal to? No. Watch this. Isn't dividing by 4 the same as multiplying by a fourth? What happens then? You get 1/3. Okay. You guys gotta remember these little shortcuts with fractions here. Fractions are your friends. Okay. We know it's opening to the right. We're centered at the origin. Vertex at 0, 0. My focus is at 1/3, comma 0. My directrix is then at x equals negative 1/3. And it's doing that. Really not too much craziness here. Okay. What's that? What do you, oh, for this? Oh, I'm sorry. Directrix. It's an imaginary counterbalance line, and I don't want you guys to think imaginary numbers or anything like that. It's a line. Bless you. It's a line when you draw it. It's always drawn with a dotted line. It's just one of those things. I completely forgot to say that. We do a lot of these little dotted line stuff in comics. Right. Well, let's see if we can go backwards. Let's write the equation. So we're going to write the equation with a vertex at 0, 0 and a directrix at y equals 2. Okay. Here's where understanding what things look graphically comes into play immensely. Okay. So when we do this kind of stuff, it's always a good idea to rough sketch. Because if you rough sketch, then you'll know the direction. And then you'll know where everything's going to wind up going. So in this one here, where's the origin? Or sorry, vertex, sorry. That's 0, 0. Everything today is at 0, 0. So I start, place a vertex. Okay? Y equals 2. What kind of a line is that? Let's say straight. No. We need to know the difference between horizontal and vertical lines, ladies and gentlemen. Horizontal lines are always y equals a number. Vertical lines are always x equals a number. So this is a horizontal line through the number 2. Which means, what direction does this have to open? Down. And why does it have to open down? Yep. Remember, this is the counterbalance. If the directrix is above, that means it has to open below. So if the directrix is 2 units away, where's your focus? 2 units away. Now that means, what's your p-value? -2, very good. Remember, the p-value is the distance from the vertex to the focus. Even though they gave us a directrix which was positive, that means that the opposite has to be the focus. So our p-value is -2. We know that it opens down, so is that an x squared or a y squared parabola? X squared. So now we write out our generic, x squared equals 4py, which means now what? What's the equation? There you go. X squared equals negative 8y. Excuse me.
Technically, we could say that is why
No. That y value is the directrix. Y equals 2 is the value of the directrix. It's not part of the parabola. This is the directrix. This has nothing to do with this y value here. Okay. The y value there is part of the curve. Okay. All right. Student level. Sorry, good. All right. Our vertex is at 0, 0. Our directrix is at x equals negative 1. But we're going to write the equation again. All right? Excuse me. So when you have a directrix of x equals negative 1, horizontal or vertical line? It's vertical through what number? Negative 1. I know I'm at vertex is at the origin. Negative 1 is my directrix. Which means, what direction does this have to open? That's open to the right. Very good. Now, if it opens to the right, is it an x squared or a y squared parabola? Y squared. So now we know that it has to be a y squared parabola. Y squared equals 4px. If my distance from the vertex to the directrix is negative 1, what's the distance from the vertex to the focus going to be? 1. So what's your p value? 1. So your answer is y squared equals 4x. Just looks weird. Okay? Just looks weird. What if you have, oh, I don't want to get too far ahead. Can I go to another one? Thanks. This is weird. You don't normally talk this much. I don't like this. So, again, see your vertex. I'm not changing vertex yet. That's 0, 0. And let's say your focus is at negative 6, or no, not negative 12 and 0. What do you think I'm going to say to try and do first? Sketching, exactly. So my vertex is at 0, 0. Where's negative 12 and 0? Up, down, left, or right? Left. Here-ish? What direction does this have to open? If my focus is there, vertex always opens to the focus. Vertex always opens to the focus, which means the distance from the vertex to the focus is the p value. How far away is the vertex and the focus? No, vertex and focus, how far apart are those two? 12. But since it's opening to the left, it is negative 12. So our p value is negative 12. This is a y squared. Y squared equals 4px, which therefore makes your equation y squared equals negative 48x. Now, if you wanted to see what that looked like graphically, what would you have to do in the calculator? Just curious if you could figure that out. What would you have to write this up as? Yes, sir. Yeah, but what would you have to do to graph that though? You're right with the square root there. What would you do with the negative though to make it work? Perfect. Put the negative in front of the square root and then do it. Okay. So if I wanted to see what this looked like, back to my x squared stuff here. So y equals. It was negative square root 48x. And then square root. Oh, I didn't put the 48 in front of it. Sorry, because it was a negative in there. Why did that flip? Huh. That was weird. Did I type that in right? Yeah. I don't know why that doesn't work right. I don't know. Whatever. But we know what's left. You're not going to use your calculator for this stuff. The thing is with the calculator on this stuff, it doesn't get us anywhere. Yes, sir. It flips it, but didn't it go? Oh, because of the. Oh, here I was thinking it wasn't going to work with the. Yeah. I was thinking it wasn't going to work because of the negative square root. I didn't do the other part of it. Then this one would be. No, because then it'd just be, well, let's see what happens. That's why we don't use calculators to graph constants. Much easier to do by hand. All right. What do you have to do here? Bless you. This might be the last one here, guys. If I want to identify focus, directrix, and do a rough sketch. What do I have to do first? Okay. Get y squared by itself. We know this is a y squared parabola because there's a y squared in it. Not helpful. Which means it's either going to open left or to the right. So we got to get y squared by itself because we know the formula is y squared equals 4px. So I would always write that down first, whether it's x squared or y squared parabola. How do you move that negative 4x then? Yep, add 4x to the other side, so you get 9y squared is 4x. Then what? Divide by 9, you get y squared equals 4/9 x. Okay? What's your p value? Well, first of all, which way is this going? Left or right? It's going to go to the right. We know it has to do this because it's positive. What do you have to set equal to 4p to figure out what p is? 4/9. I know that 4/9 is playing the role of that 4p, which means what is p? 1/9. Very good. So that means my focus, since my vertex is at the origin, it would be at 1/9, comma 0. And my directrix would be a, what is it, a horizontal or vertical line? Through what? Very good. And that's what we're looking at here. I'm not trying to get too crazy. I say it's good for a Monday, but it's Tuesday. And then you guys have another Monday then on Thursday. Super exciting. Yes, if you are not a junior, then you don't go to school tomorrow. If you are a junior, then you go to school tomorrow. If you are a junior, then you need, if you are a junior, then you need to make sure your calculator is charged. Because you can use that calculator on the PSAT. For the calculator portion of it, there's non-calculator. I think they're done 11:30-ish, 12-ish, somewhere in the neighborhood, after the testing goes through. I have you guys doing these, but I think we're starting at 39. And it's 39 through 77, every other odd. Every other odd. 39, 43, 47, so on. Okay? It should not take forever. PDF file is up and ready. We will talk about ellipses on Thursday, which is our second, or actually our third Monday of this week. Because yesterday was Monday, officially. Today's kind of like a school day Monday. But then Thursday is like another school day Monday. But then you have Friday after that third Monday, which is nice. Yeah, that's right. That's no problem. Unless, do you want to take a port and just plug it in on your laptop? Why don't you take a port and plug it in?